So good morning or good afternoon, everybody. My name's Joe Hankey. I am with Alberta Eco Trust Foundation as part of the ENBIX program, and we're here today with SSRIA doing as part of our residential building technology series. This has been an ongoing webinar series where we try and showcase different innovations that are out in the building industry and try and give some samples of what those innovations look like in practice. Today, we're really fortunate. We're joined by three speakers today, and we're going to be looking at continuous insulation and sheathing products as well as panelization and some of the things that we can learn from those processes and how they're helping industry meet the challenges today. So Alberta Eco Trust operates across Alberta, and as such, we recognize Indigenous peoples from across the province, including trees 6, 7, and 8 territories. And we take this time to make sure that we recognize those peoples and their contributions to Alberta and their ongoing contributions to Alberta. For those of you who aren't familiar, Alberta Eco Trust, we are an environmental charity that operates in Alberta. We have over 35 years of operation in a variety of areas. Our vision is in Alberta where both people and nature thrive. And we realize that vision by recognizing gaps, mobilizing resources, and investing in our communities in both creating partnerships and building capacity across the sectors. We work in a variety of different ways, including programs and initiatives, grants, impact investing, and strategic engagement across several different key focus areas, including greenhouse gas reductions, the circular economy, nature-based solutions, as well as others. And we actually have I do this introduction really awkwardly. We have a great video that's circulating right now through our website that does a much better job of sharing what we do. Within Alberta Eco Trust, we operate two programs related to the building and construction industry. One is ENBIX, which is the Emissions Neutral Building Information Exchange, and the other is the Retrofit Accelerator, which focuses on deep energy retrofits. We have a variety of funding partners that make all of this possible, including the City of Edmonton, the City of Calgary, Government of Canada, the LC3 and the FCM, as well as the Peter Gilligan and the RBC Foundation. So for today, this is our agenda for this morning. We're going to do a really short audience poll. We're going to have a quick introduction from SSRIA by Daniel, and then we're going to move through our speakers. We have three speakers today, Darrell Paul, Peter Amoroso, as well as Shil Patel. And at the end, we're going to have a question and answer period. So for the question and answer, we will be using the Q&A function. If you can't find it, it should be at the bottom of your screen, but if you don't see it right away, click on the More button. And you should be able to get to it from there. So I'm just going to bring up the poll question here. Give me just a moment. So really our poll questions are really just about trying to understand who's with us today. So, first one is, in which region do you primarily work? And my apologies for those of you who don't live in Edmonton or Calgary and you get lumped into the all of Alberta category or elsewhere in Alberta. Okay, I'm just going to give that one more moment here. Appreciate everybody for participating. Okay, we have about 70% of people responding, so I'm just going to end that poll. And we'll just share the results really quick. So, we have a distribution of people working from different parts of the province, which is great. Always like to see lots of variety there. Lots of people working in the industry and engineering industry associations, government, education, and nonprofit, planners, developers. So again, really good cross broad representation of our industry. In terms of sector, lots of residential as well as people doing both residential and commercial. Again, always good to see that. And perfect. So with that, I'm going to hand this over to Daniel. He's going to talk a little bit about the work that SSRIA is doing with their CAF project. And CAF is their Codes Acceleration Fund.
Awesome. Thank you for that. Good afternoon, everyone. My name is Daniel Benner. I'm the Manager of Industry Relations with SSRIA, which is the Smart, Sustainable, Resilient Infrastructure Association. For those of you who don't or haven't heard of us, we're a nonprofit organization based here in Alberta that works on the intersection of construction industry and the low carbon innovation space. We connect the people building the buildings with the people developing better ways to build them. We typically facilitate collaboration between three main pillars within our organization. Our business growth program, which helps startups refine their pitch, bolster their network, and give them a platforms to express their ideas in the building sector. Through our innovation fund, which has supported over 30 projects to date that have put innovative building products into real Alberta buildings, from passive house multifamily buildings to fiberglass curtain wall systems to the kinds of products you're about to hear from today. The last pillar that helps bolster last pillar that kind of works in our organization is set to bolster the ecosystem by providing networking opportunities and the dissemination of information and learnings from our projects so they can be scaled and replicated across the province and beyond. One of the things that we kept hearing from our projects, from builders, from manufacturers, and everyone involved was essentially that the product works, the science is there, the testing's there, but getting it through permitting is where this begins to fall apart. Same products, same documentation, different municipalities, different outcomes. So we decided to do something about it. We applied for the Natural Resources Canada Code Accelerator Fund funding back in November, and basically set off to understand why this is happening and build a resource to address it. Over the past few months, my colleague Con Ozadurak and I have conducted many stakeholder interviews across the province with builders like Brookfield and Mattamy, manufacturers, including a few of the folks presenting here today, municipalities, including Calgary and Edmonton, the Safety Codes Council's Innovation Hub, and municipal affairs. Essentially, trying to speak with anyone who touches the alternate solution pathway, and we've had or plan to have conversations with in the future. What we found so far is that the building code has a lot of the tools for innovation, and you can see kind of the two different pathways or multiple pathways that you can see on the screen here. The code is essentially designed for alternate solutions. The gap isn't that the code itself, but what we're finding is from our perspective is that there's no shared, call it playbook, for how to navigate that consistently. That's what we're building, and that's kind of our end goal. We've partnered with LRI Engineering, who's a building code and fire protection consultant, to develop a technical backbone of a low carbon approvals guide for the province. Think of it similarly to the City of Edmonton's point access block guide, but focus more on the innovative materials and assemblies rather than building form itself. We've also partnered with the Safety Codes Council's Innovation Hub, so the guide serves both sides of the table, creating a guide that helps applicants submit the complete package and gives reviewers a consistent framework. Hopefully, this is intended to move the needle for everyone involved in the alternate solutions pathway system. We'll be sharing this research more broadly later this year, and we're targeting a final guide by early 2027. If any of this is relevant to the work you're doing, I'd highly encourage you to reach out to myself. And whether you've got a product going through permitting, a project that's kind of hit a stopping point, or just want to stay informed as the guide develops, we hopefully want to stay connected in that realm. And if you're not already connected with SSRIA, please sign up for our newsletter at sria.ca or ask me further about memberships. I can kind of touch base after the fact here today. We're building an ecosystem around the industry and would love to connect with you all. You're here to learn a little bit more about the products that are making these buildings perform better. And you've got three great products that are going to be speaking about that today. So I'll hand it back over and thank you for the time.
Awesome. Thank you, Daniel. So with that, I'm going to rest control here and I'm going to pass it over to Darrell. Perfect.
There we go. Do I have the right screen up, Joe?
Yes, you do. You're good to go, sir.
All right, sounds good. So I'll just introduce myself. My name's Darrell Paul. I've been in the industry for about 47 years. I started as a framer. I spent some time as a site supervisor. Then I spent almost 30 years as a building envelope technician. And then about 2 years ago, I got introduced to BTRboard. So BTRboard is a fairly new product, but our claim to fame is basically it's an insulated sheathing that has a nail backer so that you can fasten in a simple way. We have three different main products. So if you look at the left side, you see the BTRboard OSB. So we have an integral foam core. It's a thermoset foam, which is a polyiso. And when you look at that material, it's got a 7/16 OSB on the outside and a fiberglass facer on the inside. The concept is to try and replace existing sheathing with an insulated sheathing in a cost-effective way. And you can see some of our certifications at the top. We have fire certifications for our Fire X material in the middle, which helps us to be able to be used on fire-rated assemblies within things like zero lot lines. The other thing I'll mention is we've been working with a foam corporation, Woodbridge Foam Corporation, which is a multinational company across the globe that produces all kinds of foam. So their specialty is designing and the chemistry behind the foam. So we've been working very closely with them. So I guess you could say that we're a foam company first, and then a construction company secondly. But when you look at our product itself, how it's manufactured is we take our materials and we inject a thermoset foam, which is a polyiso or a polyurethane foam, onto the board itself. And you can see that the substrate, it creates a monolithic bond between the two. So you have a very strong material. It doesn't come apart in the cold or in the heat, and it stays bonded together to create that strong mechanical bond. Now, one of the things that people are familiar with is when you add exterior insulation, if you look at these three slides here, you'll see that you've got a standard wall on the left, you've got our 19 bats, and the exterior sheathing is going to be, cold in the wintertime. When you add insulation to that wall by trying to just add thicker insulation or higher R value, you end up with a bat that will reduce the amount of heat that will reach the sheathing. And so that's not the most effective way because the sheathing gets colder and colder. So you increase a risk of the sheathing. So on the far right, you see exterior insulation. In this case, it's BTRboard. When you add an exterior insulation, you're warming the surface. You've got a surface that's not subject to mold or mildew and doesn't absorb moisture. So one of the reasons that BTRboard was designed was to be able to accomplish that and increase the performance ability of the wall. So you get the full R value of the assembly in that total wall. Now, when you look at the streamlined process we've tried to create, you can see on the top left, the boards come out in pallets and they are already pre-manufactured together. On the top right, we have a fire-rated assembly for our zero lot lines for ease of construction. Bottom left, we've tried to keep the process unchanged. In other words, the framer installs the material, he stands the walls, it's ready to apply your house wrap and your siding to it. So without changing too much of the construction process. And then on the far right, one of the details that we have to consider is window installations. So for window installations, we've come up with a way to support the glazing in the glass, whether it's a flange window or whether it's a standard window, we have an application for both of those. So what were the problems that we were trying to solve? Well, our goal was to try and find a way to simplify construction while adding exterior insulation. So when you look at the complexity on the left, you've got foam being added to the house. You can see the amount of work it is to add that extra foam. You've got picture framing around the windows to support them. Now you have to put strapping on. So the labor and the sequencing become a detail that, or a consequence of that detail. And then the cladding detachment complexity of trying to make sure it's flush and even, that creates problems. So when you look at the performance goals, we looked at something that would give us a high R value per inch. We looked at vapor permeance, compressive strength, fire performance, structure and shear, as well as reducing mold and moisture risks and moisture absorption. So those were the goals that we went with. And when you compare the outcomes and you look at what we're actually building, you can see in the close-up picture here, the Barrier Tech board, which is a fire-resistant board. It goes nicely with the foam, which is a low uh, combustible foam and a low heat production foam. But on the right-hand side, you can see that, a builder like Jamin will put it on their houses and they'll install it, put the house wrap on, and then they can carry on with the same process that they did before without having to add too much complexity to the installation. But one of the challenges we found, and I kind of equate it to like a combination lock, right? You need to know the exact numbers. You go to the one, you go to the right, a certain number, you go back to the left, a certain number. You need to know the code. So what happens is if you look at the upper line here, we have improved structure. Well, as soon as we try and change the foam, that impacts the moisture in the fastening. Okay, so we make an adjustment to that. Well, now if we want to improve the thermal resistance, that impacts the thickness of the foam and the detailing that happens. If we look at the improved fire, well, that impacts the material behavior, such as vapor permeance or R value, and the system design. And then the other thing that we're really interested in is reducing greenhouse gases. Well, as soon as we try to reduce the greenhouse gases, you get into materials that have lower R value and it changes the material chemistry. So what we found as we went through it was that the innovation it takes to create a simple product on site takes a incredible amount of time to develop in the lab and in the process. So it's not just a matter of taking a board and putting a piece of foam to it. It's figuring out how those work together to give you the best type of final product. So innovations, optimizing the best way to use the materials, the best type of materials, the best materials together. And then we need the whole system to work together, and not only that, but it has to comply with the building code. So when you go to the AHJs and you say, we have this new product, the first thing they want is engineering on everything. And so to be able to provide that, we have to do a lot of different testing. Now, some of the testing that we've done, which has helped us to meet the building code requirements, is if you look on the left box here, you see the structural tests that have been conducted. So we have pull-out tests. So how well does the anchors or the fasteners hold the materials? Can we use a standard nail? Well, absolutely we can. But the size of the nail, the type of the nail, the head shape of the nail all makes, you know, something that helps us to understand how the system performs together. But when you also look at things like how do you fasten cladding to this? So it's not just providing exterior sheathing, it's providing a system. So people are going to ask you, how do you attach a deck trimmer to it? How do you attach a roof connection to it? How do you put stucco on here? How do you connect the corners of the stucco? So there's all these different variables that have to be addressed. So the pull-out testing had to be done. The shear wall test, we have two different types of shear wall tests. One is the shear wall in racking strength, but then there's also the out of plane test. How does it react to wind and how does the performance get affected by that? We also have the seismic cycling. So building codes, we know that the new 25 building code is coming out and we've already seen it adopted in the BC market. So now we have to make sure that we can adjust to the markets that have higher seismic loads. And so we've tested to all those parameters. But the other thing we looked at is on the right, we looked at the fire testing. So with the introduction of zero lot lines and materials that, are affected by fire, we have a few different tests here. So if you start on the right over here at the ASTM ED4, that tells us whether we're a class A, B, or C foam, but it really doesn't affect as much of the performance of the building as do these other three tests. So for instance, The exterior wall fire test, how far does the fire climb up the wall? Well, we've tested against that to the S134. We've tested against the next one, which is the S101. So we have a 45-minute rating under a structural load. So for 45 minutes, you can get out of that building and you can make your escape if there is a fire. But the one on the left was the interesting one, the cone calorimeter test. That one actually tests how much heat is produced. And when you look at our BTRboard thermoset foam, we're about 20 to 30 times lower heat production than softwood lumber. So that helps us to look at the system and say, how is it going to perform in a fire? So when we did the 134 test, I'll show you a little video here on the right. You can see that the vinyl is melting off the exterior wall, but the BTRboard itself, the fire rated Type X material on the outside covering the foam. If you look at the picture on the left, you can see that, the circle on the left is where we took the cutout later on. Up in the middle top center section, we took a chunk of foam out after the fire. And I'll just point out that that fire, the flames coming out of that opening is about 2000 degrees Fahrenheit. So that's well beyond what typical foams can handle. So a thermoset foam doesn't melt, it doesn't drip, it's not flammable when it heats up like styrene foam. So that's one of the reasons we decided to do this. And when we compare the NIST ratings, which is the fire ratings of different materials, you can see that, at 30 to 55 kilowatts per meter squared, we're significantly lower than other types of materials. So that helps us to pass some of these tests so that we can assure of the performance. And then when you get into structure, the same kind of thing. What is the structural performance of the wall? When you look at a typical wall like you're seeing here, as you put it into that cyclic motion and it's moving back and forth, when you compare what our BTRboard walls in shear and ductility do compared to the other standard walls, we get an idea of how we fit into this assembly and where we fit well and where we don't, and where we have to make improvements. So, as we develop these products, we have to make different improvements as well. We also looked at the complexity of the materials and we said, okay, so what does a nominal wall insulation have? So you have the first column, what's an effective R value of a wall? And when you look at the upgrade costs and say, okay, to add this amount of R value, what's the net gain in efficiency? And looking at the cost per square foot of effective R value added, we found that because of our ability just to slip that material in when the framers are framing the wall, we have a very low cost per square foot, a very low cost for added R, but it also gives us a net gain in efficiency that is right up there with other materials. In fact, supersedes a lot of other materials. So thank you for the opportunity to present. I know it's a quick, short presentation, but if you have any questions, my information is on the slide here, and you can also get it from ENBIX or from SSRIA.
Awesome. Thank you, Darrell. Appreciate that. And like I said before, like I said, if you guys have questions that you want to direct towards Darrell, just throw his name or throw a BTRboard into the question under the Q&A format. So now I'm going to pass it over to Peter Amoroso. Peter, if you want to share your screen.
I'll do that now. Can you just confirm looking at the right screen here?
Yes. Yeah, we're good to
go. Okay. Hi, everyone. My name is Peter Amoroso. I'm the marketing manager for SIS Panels. I have about 5 years experience in the construction industry, but our founding team has about a collective, I think we're at 60 years now, of experience both inside and outside of buildings. So just to jump right into it, at our core, we're our name, SIS Panel, stands for Structural Insulated Sheathing Panels. And as Darrell beautifully put, it's all about combining exterior insulation with structural sheathing. That way you can speed up energy efficient construction without fundamentally changing how things are done. Because with our panels, the insulation always sits against the studs and that sheathing faces outwards, you have that continuous nail base across your home that you can install all sorts of different sizes of claddings onto. Our claim to fame is that our panels can be customized to the project. We can vary the different sheathing type, insulation material, the thickness, or add backer boards to meet different building codes, climates, and performance requirements across North America. Like, for example, right here in Calgary, we worked with Trico Homes at the start of their Kingslands Junction project. When they were designing their first building, which is now their head office, they had largely set the budget and wall assembly design, but we're looking at ways they could add exterior insulation. So they approached us with a simple question of, is there a better way to do this than how we're currently thinking? Their assembly at the time, a fire rated assembly, utilized Densaglass sheeting to get to that fire rating, along with the Z-girth system to support their exterior cladding. From a code and constructability standpoint, this of course works, but that Z-girth system represented a significant portion of both the material and labor costs going into this project. So when we reviewed this, we saw a real opportunity. They could not only increase the performance standards, but save time and costs while doing it. So this is the assembly the project ultimately ended up moving forward with by using an insulated sheeting built with magnesium oxide board, as you'll hear from Shil in a little bit. Great material. This material is able to speed up the installation by eliminating a step while adding exterior insulation. And like I said, this project eliminated your Z-girths because that magnesium oxide had a significant strength, more than enough to hold that exterior cladding. The particular board used had a nail pull-out strength of just over 600 lbf. So by removing the Z-girths and freeing up that budget, they can have a higher performing building without fundamentally changing how they do things. So this really just demonstrates that projects can operate at lower costs while hitting the performance requirements of tomorrow. And that's really what exterior insulation is best at, maximizing the components of the materials you're using. Like, for example, fiberglass batt insulation, it doesn't perform as well as other in-batt insulations like spray foam or cellulose. And one of the reasons for that is your installation sensitivity. Batts can be prone to gaps, compression, settling, which all creates air gaps in the walls, which allows a convective looping to happen. As your warm air rises, the cold air falls. And this temperature changes just makes your assembly work way harder than it has to. And adding even just a little bit of exterior insulation can help solve this problem. So an insulated sheeting is not only just about adding R value to the exterior, but making the entirety of your assembly work better. But that's not the only thing. There's also construction benefit, because when your buildings are enclosed faster during the construction process, they're going to need less temporary heating during the winter. That means burning less propane, using less fuel, and lowering your construction emissions even while the project is being built. But one comment we get from a lot of designers is, once they decide to add an exterior insulation, is what materials do you even use? And that's why we really focus on customization, how you can different designers prefer different materials depending on the project's priorities, the climate zones, and etc. So that's why we let designers mix and match the different product benefits of the sheathings and insulation types. And this works well to meet specific building codes in different parts of the country. Like, for example, we work with several home builders in BC where the area they're building in, if you want to install cladding directly into the OSB, you need to use a 15-30 seconds OSB. And with our customization, we can simply swap in a 15-30 seconds instead of a 7/16, no problem. So this versatility allows designers to simplify their assemblies without otherwise complicating the process when they're trying to integrate these types of materials. So the result really is fewer compromises, fewer substitutions, and a wall system you can easily adapt to the needs of the project. Like, for example, lowering your greenhouse gas emissions. Because we offer all of these different insulations, it gives designers points that they can target. Now, the numbers on this slide show the global warming potential, And these are all directly from the EPDs of the insulations we use. And this represents the values through A1 through A3. So that's the manufacturing footprint of this. So like, for example, another reason it's good we can swap out different materials is that the mineral wool shown on screen here, that's an Owens Corning product. Now, it comes at a premium, but for builders to have this in mind, this emissions reductions in mind, then it's a great fit. However, for builders where maybe that isn't their number one priority, they could use a different mineral wool market on the product, given it has similar testing, and save costs, because other mineral wools on the market, they have up to 5 times the EWPs of what's shown here on screen. And in some cases, it even allows us to adapt systems builders are already using to better meet their needs. Like, for example, right now we're working with an architect in Seattle who's a big fan of the ZIP system, the OSB that has a green integrated water and air barrier directly into it. They also have a version of the product, an insulated sheathing that utilizes a polyiso insulation. But this architect is trying to get away from all types of foam exterior insulation, so approach us about modifying the system they already know and they already use and trust with the different types of insulation so they can better meet their requirements instead of abandoning a system they're already comfortable with. It's all about trying to keep the system they liked while trying to align it with their project goals. So we've looked at how material choices can reduce the carbon on your assembly, but even the best materials only perform right if they're installed correctly And that's where resiliency comes in. A resilient envelope is designed to maintain its performance, because when an assembly fails, it's not just a maintenance issue. You're installing these individual layers over and over again. And each repair cycle can create new embodied carbon issues, requires transportation, reconstruction, additional energy, man time, labor, et cetera, et cetera. So by using integrated systems, you have a better chance at eliminating or reducing, I should say, your repairs, you're lowering your long-term emissions, and your wall should perform better if there's less opportunities for error. So like, for example, we're working with an architect in New York on a big pool complex. And we're looking at roofing panels also using magnesium oxide board. So they came to us with the ask of integrating a two-way cross to allow airflow in all directions within their roofing assembly. The goal was to avoid having contractors build a complex system that could easily fail through disruptions in the design intent and how the architect did it. So this is the design that's currently getting tested right now. This includes a 1-inch diameter air channel that runs both vertically and horizontally at 6 inches on center throughout the entire field of the panel to create that continuous airflow around it. So regardless of how the panels are staggered, you always get that airflow around it. So this is just an example of how we're trying to incorporate resiliency into different assemblies without fundamentally changing the construction process that goes on behind it. But new construction isn't the only place where a product like insulated sheeting shines. It's also a great fit for retrofits. So all these performance benefits I've discussed, like your performance, resiliency, efficiency, it all makes it well suited for retrofits as well. Like we got to deal with this 18% of total GHG that's coming from all our current buildings right now. So because insulated sheeting goes on your exterior, it keeps your interior untouched. So it's easier to do these types of renovations, especially when the envelope is one of the major areas improvements need to be made. Another case study from here in Calgary is a church that approached us. They wanted to reduce the operational energy costs and improve the comfort of their building during large gatherings, especially. But they didn't want to touch that beautiful cathedral ceiling you can see there made out of cedar planking. So they approached us about doing an exterior retrofit for the building, and we ended up recommending a custom panel utilizing 8 inches of GPS insulation as the core to add about R40, and then cut to the roof pitch along with a slot for your 2x4 studs to support your cantilever systems. So this is all just an example of the custom cutting that's possible with us in order to save that additional time and energy on site. The installer found it was very easier to work with. Didn't really need to modify much from their planned way to do it, which you can see on the left. By simply combining several steps into one, they're able to save about 3 steps of their process. The only catch to this from a design perspective is that there isn't staggered seams, but that was the only fundamental difference in terms of the constructability of this project. Then after the panel was put down, all they needed was a peel and stick, and shingles can go right in. So the result was a simpler and more consistent installation that maintained their energy requirements while saving costs. So the installation ended up being about 20% faster compared to how they were planning to do it. But products like these, as was mentioned already, it does come with some barriers to adoption, like regulatory and code familiarity is definitely one of them. Many of these solutions are new to code officials, and all these codes are written around traditional site-built assemblies. So even when solutions are tested or even have approval as alternate solutions, this can still be a barrier when talking to different municipalities. And then your industry practices are another one. Your construction teams are often relying on their time-tested methods, and introducing a new system can feel risky. So while we try to eliminate this as much as possible by keeping the installation similar, as Darrell was pointing out, this still can be a challenge and at least a conversation with your framers to make sure they're getting all the details right around stuff like corners or windows, et cetera, et cetera. And then the last one is perceived cost versus life cycle value. Anyone who sees a higher upfront cost versus how they're currently doing it, that's immediately a bit of a red flag. But it's all about working them through the details to show how it's not just about the upfront cost, it's about how the project performs over its lifetime and as it's constructed, because it's all the little details that really make a difference. And understanding these barriers at the forefront of deciding on a solution like this can definitely help you plan effectively. So solutions like insulated sheeting can fully deliver their full performance, efficiency, and environmental potential. So yeah, that's a bit about us and what we can do all in a nutshell there. If anyone has any questions, please submit them in the Q&A below, and me and the other presenters would be happy to share our insights on it.
Awesome. Thank you very much, Peter. And we will move quickly over here into Shil's presenting now.
All right. Thank you, everyone, for joining us today. I would like to introduce myself. My name is Shil Patel, VP of Sales and Business Development with ZS2. I've been in the industry for about 12 years now, from design to manufacturing, assembling the panels on site, now taking on the BD role, so knowing the full life cycle of a project and understanding how our systems work. Today, I'm going to be presenting one of our assemblies, which is our 3-in-1 SIP panel assembly application. This is basically structure, sheathing, and installation all into one, a SIP panel assembly. Just a little bit of history about magnesium and what we're going to be talking about today is just identifying the history of magnesium, explaining the climate risk zones, and talking about building code changes to material performances, identifying key related hazards around building environments. And then secondly, analyzing material selection. So when we look at high risk zones and fire exposure to flood zones and so forth, and why these materials are becoming more prevalent in those areas and being utilized there, to where insurance is also starting to adopt it more as well, to a real world application and showing you one of our projects that went through a recent forest fire. Okay. So just a little bit of history of magnesium. Magnesium cements predominantly come from China, North Korea, and Russia. So 3 very difficult places to work with, as we know, but at the same time, the reason why is magnesium is high production in those areas and not in North American market is because we have 3 mines that are located in North America, and most of them are used for pharmaceutical and animal filtration. So pharmaceuticals make more money than building products do, so they tend to want to utilize it for that. A lot of the magnesium boards on the market are imported in, most of them are, and there's over 130 different boards on the market. We've tested ours to a certain formulation to be able to be utilized into the North American market and be adopted into Canada and the US. The big thing about magnesium cements is that it isn't a new building product. It's been used in the Great Wall of China, the Roman aqueducts, and the Brooklyn Bridge. So it's been used, it's an ancient technology, but revitalizing it for building products in the sheathing application. Just want to hit home on like some of the key factors to what's happening in the world. We know that there's more fire risk happening, flooding, and as climate changes are occurring more and more, there's more risk to using standardized materials that consistently fail. And so we need to start thinking better and building better and smarter overall to be able to provide a safer, stronger, more resilient home for the homeowners or even structures in general. And understanding what that could be for insurance purposes, high risk zones, and then being able to be a homeowner and not having in a high risk zone to be able to fail over time. A lot of magnesium cements have been tested, so I do want to hit home on ours. We have our ICC certification for the US market, and then we are certified in Canada as well within our CER, and then we do have an EPD around our panels. So magnesium itself is a very low carbon intensive process. So it has a very low carbon output. It's actually a tailings of Portland cement. That's one way to actually secure magnesium is the limestone production that comes off to create Portland cement is magnesium's a byproduct of it. So utilizing some of that and repurposing it into building products has been a very good way to look at an environmental product declaration and utilizing it into panelization as well. MGO adoption across the industry, we have tackled multiple different areas into construction. One of our biggest areas is residential. We do a lot of houses with SIP panelization, and I'm going to get into that a little bit more to commercial, mixed use, multifamily, up to 6 stories. We've built standard stick frame, or I'd look at it as using lumber, but with panelization. So eliminating the 16 on center studs and going to a 24 on center stud package or to a 48 on center stud package. And I'll show you what that means in a second here. So the real world outcome, this is one of our projects in Tasquia First Nation in Split Lake, Manitoba. As we all know, the fires in Manitoba were devastating last year, and one of our recent projects that was built over the winter of last year went through a forest fire. And this is just a short video of showing them as a helicopter ran through it. And it's showing that the building was untouched because they had appropriate setbacks. They had appropriate layers to the construction process. So when we look at a building like this, we're not just looking at our product being a bulletproof system. It's a layered approach. It's all the other factors around those systems that protect it. MGO cements are fire, mold, water resistant. It's 50% chemically encapsulated water. So as fire is present towards it, it's actually producing water vapor, not any kind of off-gassing material, which is a benefit. In this type of structure itself, we were fortunate that nothing burnt down. What happened was one of the windows blew out and smoke got into the ceiling and literally charred basically the ceiling tiles. Other than that, the building was untouched. And this is why insurance companies are looking at us right now with our panelization for further discounted rates on COC policies and insurability because they didn't have to pay a massive premium on this house on this structure. Now, when we look at magnesium cements, as I mentioned, it's not fireproof. It is a fire-resistant envelope. And so understanding building science and understanding how you're going to be constructing using these types of products are going to be very important. So as both my colleagues have mentioned, Darrell and Peter, it's a layered approach. And so thinking about how you're approaching a building, whether it's cladding to panelization such as ours, you still have to wrap it. The magnesium cements are not weather resistant. They need to be wrapped. They're a porous board. It's concrete. So knowing that it'll gather moisture, but then release it, it needs to be able to breathe overall. So adding appropriate air barriers and vapor barriers to the system itself is going to be important to seal it up and then putting on your final cladding. Our boards have a 280-pound pull strength. So on the interior side, we can hang TVs, cabinetry, things like that right off the surface of the board. The assembly of this panelization was a three-in-one application. So double top plate lumber, lumber at 48 inches on center for vertical, and a sill plate on the bottom. And what that looks like is basically like this as a demonstration here. Going through it all, what we did was we created half-inch sheathing on either side, an EPS core foam, double top plate, vertical seams at every 48 inches, and a single bottom plate. We also have a 1 hour fire rating on this assembly itself. You would have to add lumber at 24 to accommodate for the fire rating. The project that I was showing you to date was at lumber at 48 inches on center. We also include vertical chases and horizontal chases for plug and switch. So feeding electrical wires through there, we're trying to think of ways that contractors can understand our systems to be friendlier on site and not just a friction point overall with the course of using SIP panels. An average weight of these panels, a 4x8 panel with the lumber included in it, is 250 pounds distributed, and two individuals can lift and put the panels into place. If you needed to sling the panels in, just because you're on a 2-story, 3-story application, we provide lifting bolts, which are retractable. And then these bolts that are inside the panel on the first top plate would basically get hammered into the assembly. And then the second top plate unifies multiple panels. How to connect everything together would be a tongue and groove application. One of the panels would have a recess of 1.5 inches. Lumber would be protruding 1.5 inches. And you have two different kinds of adhesives that lock the panels into place before you nail it off or staple it off. You have an add fast spray foam from lumber to foam connection to seal up that air cavity. And then you have a PL premium bond from board to lumber connection to seal up that joint. There's usually an 1/8 of an inch joint between each panel just to allow for movement and not tightness towards each panel. And then you seal it with a caulking material. Other than that, you can use 7/16 crown staples or 4-inch ring shank nails. There's two different kinds of boards on the market. There's a magnesium oxychloride, and then there's a magnesium oxysulfate. We are the sulfate-based board. And so knowing that, less corrosion risks around it, but using appropriate stainless steel fasteners or coated screws are going to be appropriate in both board applications. From there, our R values. We typically start at 6.5-inch thick walls for exterior, and that's what we specialize in. Typically, the interior walls are going to be stick frame. There's not really a need for us to be able to have to put a panelized wall into the interior where we elect not to do it. If a client asks us to, then we would. It's just the cost associated to it. We're just giving them the benefits around just using it as an envelope structure. You can use the sheathing and replacement for the interiors. The big thing, this was a 2,500 square foot build in California. I was building this one, 3 guys, and we put it up in a day and a half with 68 hold downs for seismic capacity, knowing that we're seismic compliant up to category D. And then if we need to go up to category E, we would have to just look at some moment walls to take on some additional load capacity. We are 1 and 2 hour fire rated for the walls, and then we are also hurricane and fire resistant as well. From there, there's just a quick little demonstration of our panels going together. When we talk about our assemblies and how we operate as a company, we typically take an architectural set from a client, and then we create an engineered shop drawing set, which is stamped by one of our engineers or a local engineer, ones that you have. And then from that aspect to it, you're able to create an installation set. The installation set is what I'm going to show you next. But we have everything built to RL schedules. So all your headers, your sills are all built into place and already framed in so that you don't have to worry about that on site. Your sheathing, your insulation, and your lumber. You can also interchange the lumber with steel. You don't light gauge steel if you needed to. We don't typically do it often, but if a client requests it, then we will build it. It's customizable to dependent on what people are looking for. This is the project that was in Tasquia First Nation. So I just wanted to show you what a plan set would look like for permitting. We do everything in Revit model. We provide all the kits to it, details, packages that are associated to our structure itself. And what it would look like for an installation set, our PMs and our designers are on every single job. So you'd have a dedicated project manager to your project from the life cycle from start to finish. The longest period of time in our cycle is the design permit stage. Other than that, the manufacturing stage is quite fast. We can pump out around 1,000 square feet of panel in an 8-hour shift. If we needed to go further, then we just add more shift to be able to carry on further. This is showing you an assembled panel to an exploded panel. So just showing you how everything gets connected together for the field. So when contractors or framers look at it to install, we're giving you the error indicators. We're also on site making sure that it's supported through it. And we're also giving you tags. So knowing that each tag has to face the outside of the wall, it's a good check for a framer to just do a walkthrough, making sure that every tag's facing the outside. If you ever see a tag facing the inside, that just tells you that you should stop construction, make sure that that panel actually lives where it should live, and then reassess to keep continuing forward. Our detail packages come as well, depending on how we're applying to our assemblies or what applying to the structure itself. Foundationally, like stem walls to piling, we would incorporate it, but it would be done by others, and then we'd show you exactly how to connect our panels together. And then from there, it's just explaining that we're not a fireproof assembly, we're a fire-resistant assembly with a layered approach, having fast airtight enclosures, meaning better assembly processes, faster construction processes on site. The more you pre-plan to be able to deploy materials on site for effective and purposeful usage is going to be the best way to build it. Once it gets to site, just pre-planning ahead of time to making sure everything goes as smoothly as possible. If you do need to modify a panel, we have procedures to do so. If you have a longer run of panel, we have procedures to do so as well to kind of accommodate to modify everything. Other than that, and then going into the Q&A.
Thanks so much, Shil, and thanks to all our three speakers. Just going to jump into the Q&A. So again, just a reminder that you can pop questions in there. We don't have like a huge group today either, so if you want to raise your hand and ask your question out loud, that's totally okay. We do have one question in the Q&A for SIS, just asking if the composite panel structural or just the substrate?
We have two different versions of our panels. One that is a sandwich panel, like you could see here, and another that's a one-sided version of it. The two-sided versions of our panels offer much more structure, but they're not the entirety of the structure of the building. That's always going to be your framing members. And so while it can add more and definitely assist with it, it's not the entirety of the structure.
Excellent. Just checking to see if we have any other questions that have popped up for any of the speakers. And maybe while folks are thinking of questions or typing those in, maybe one thing that we can either have everyone answer and wrap things up for this afternoon session. I think a number of you had talked a little bit about some of the workforce barriers, and I'm curious if you have thoughts around how we resolve those, really as an industry as a whole. Is it, as we go through one-off projects, we're training trades, project to project to project, or do you see a role with, education or trades training that might support kind of accelerating the adoption going forward? Any thoughts on that?
I would say that, when you're looking at the training of the trades, one of the things to consider is how far do you deviate from existing construction and what does that do to the training? So for instance, if you're doing panelized systems, it's a lot easier to train people on site, because you're just really taking the system that's already been designed and engineered and plopping it in place. If you're doing a system where you're adding one component or swapping out one component, then again, it's relatively simple. But when you're doing systems that require thinking ahead and thinking about, for instance, how do I integrate the weather barrier? How do I integrate the flashings? Where do I put the weather barrier? Do I put it outside of the foam? Do I put it inside the foam? Do I need it? That's where the challenges come. So the closer you can get to either existing construction or doing it a full panelized or modular system, I think you can capture all those things. Like when you're doing it in the factory, it's pretty easy for somebody to walk around and go, ah, I can see where this is not going to work versus on site where you're relying on a site supervisor. So
Any other thoughts on that, Shil or Peter?
Yeah, from my perspective, the way that we've approached it with trades is that we have a bunch of build partners that are also training trades as well. So they use our product. We bring out new generals, framers, and do a builder day within our facility and have a bunch of different kind of mock-ups that they can put together and play with so they understand. It's literally adult Lego blocks that we do. And so having to put up adult Lego blocks and understanding how these systems work for speed of construction is important even to the framing and the general contractor because speed is obviously profit, right? So the faster you get something done in the proper way and with precision, it gives them the ability to move on to the next job and make more, is how we look at it.
Yeah. And sometimes seeing is believing, I suppose, right?
Yep.
Break down some of that resistance.
Yeah.
Excellent. No other questions have popped up. Joe, I'll turn it back over to you.
Awesome. Thanks, Pam. Yeah, so really appreciate everyone's participation today. Really special thanks to our three speakers. It's really interesting for me watching your presentations to see some of the commonalities in the products and the services you're offering. It's really exciting to see our manufacturing industry responding to the needs of our builders and delivering products that are trying to address things like labor constraints, constructability, environmental and energy performance, as well as that really critical resilience piece, and really seeing that across all the like that was I think a common message in all three presentations is we can build really resilient structures. We talked a lot about fire. With the products we have available, and we can do that while meeting the needs. I think both, Peter and Shil, you guys both touched on sort of the services you guys offer to builders and designers, and Darrell too. I mean, in terms of the flexibility of the product range. So it's really exciting to see our industry responding and really delivering these innovations. And these ones are also, I think, from my perspective, the fact that we're now talking about things that are market ready and that are going in at volume, and trying to introduce that now to a bigger and bigger building audience. So with that, thank you very much, everybody. Appreciate your time. We are going to be back again. Pam and I are working on plans for the next in our series coming up here. So look for new announcements on that soon. And yeah, well, thank you very much for attending.